I want us to proceed to this. If they ask for any insoluble salt, any, I think we can now get one. An example is barium sulfate. You can get barium nitrate and add sodium sulfate. Or you can get barium nitrate and the which acid? You want barium sulfate. You want barium sulfate. How do you get barium? Sulfuric acid. Thank you. We want lead 2 sulfate. Lead 2 sulfate. There are many. If you want lead 2 sulfate, you can use lead nitrate and what? If there is no sulfuric acid, which other salt can we use? Yes? You can use the salt of either sodium or potassium. Now you have lead nitrate. You want a sulfate. You use any salt that has a sulfate in it, like potassium sulfate or sodium sulfate. Since they are more reactive than lead, they displace the nitrate from lead and give a sulfate to lead. Is it clear? Yes? Letitia? 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 Peace? Peace?
Yes, teacher.
Okay. You can now come up with an insoluble salt, isn't it?
Yes.
We are about to finalize this topic, and then at the end of this topic, we shall also look at we shall give you some other work. But now I've decided to be showing you how those questions come about so that you get ideas of passing chemistry. Okay? Sheena?
Yes.
Sheena? Sheena? Unmute and talk. Ready? Ready? Ready. Where are you? Sheena? You have just come in or you were there? Yes? Were you there in the first session? Okay. Since those salts are few, insoluble salts are few, we have barium, we have lead sulfate, barium sulfate. Yes? Since they are few, also their methods are few. The methods of getting them are also very easy. So I don't expect to waste time there. You see when there are few examples they are given so you can get the rest. Now, there is this way of preparing salts by direct synthesis. Direct synthesis. Direct synthesis, not sincere. Cynthia might say direct Cynthia. So salts obtained by direct synthesis. Salts containing 2 elements are called binary salts. 2 elements, only 2 elements can be prepared by direct synthesis or direct combination of the 2 elements. Let me hope this English is as clear as that. You get 2 elements, and the easiest word is fuse, or if you don't want to use this, you add, or you pass one over the other. That is what we call direct synthesis. So examples in the preparation of sodium chloride, sodium and chlorine is used. So burning sodium is lowered in the jar of chlorine. Then sodium continues to burn in chlorine, forming white fumes of sodium chloride. Now, this is what you form. Get chlorine gas. Now, which one of the two is heat? Take note of this. Burning sodium is lowered in the jar. This jar has chlorine gas. So this sodium continues to burn in chlorine and gives what we call sodium chloride. So that is the easiest way to describe this. Otherwise, other salts made by this procedure, you can get magnesium, metal, and pass it in chlorine. You will form this potassium chloride. Also, you can get iron 3 chloride, zinc bromide. Zinc bromide. Get zinc, put it in the jar that has chlorine gas. So this zinc is burned and lowered in the jar that has chlorine. It will continue to burn to give this zinc bromide. No, if you want chlorine zinc chloride, also do the same for this one. But we saw different methods of getting zinc chloride. So we don't expect you to be using this for getting zinc chloride, because there are other methods of getting it that are quite easier. So here you can get a bromide. So take note of these salts. Just get, who is shouting on the ground? Letitia. Letitia, please manage your microphone. So other salts include this: magnesium chloride, potassium chloride, iron 3 chloride. You can just get them and fuse them together. Pass a metal on the gas, you will get a salt. Now, any question before I jump anywhere? Questions? Unmute and ask questions. Unmute and ask questions. I expect questions from Uday, Barat, Peace, Phyllis, Patricia, Redi. There are many questions here, about 17 questions. Who is starting? Unmute, unmute. Andrew. Now somebody is asking, what is a bromide? Those are the questions I expected people to be asking. A bromide is what? It is a gas. It is a group 7 element. When you go to group 7, the first element is fluorine. The second one is chlorine. The third one is bromine. When you go down, you get iodine and then astatine there down. So when bromine reacts, you don't form bromine, you form a bromide. So a bromide is a radical. It is there. It has a valence 1. Since it is the group 7, it only lacks 1 to be full. Have I answered your question, Elizabeth?
Yes.
Okay. So when a chlorine reacts, it forms a chloride. You get their names? Yes? When iodine reacts, it forms iodide. Chlorine forms a chloride. Bromine gives us a bromide. Yes? More questions? Yes? We don't have questions.
What's synthesis in chemistry?
Synthesis. when you want to, actually, let me use the simplest English you can ever use. It is synthesis. Synthesis is just making something out of maybe one or two simple things. You get it? You want maybe, if you want soda, you get acidified things, all those things used for making soda. Make them together. You are using those things to make soda. So in the process is called synthesis. Yes? Letitia?
Pardon. Pardon
Yes?
your explanation.
You want the explanation of synthesis? Synthesis is, if they say you want to synthesize something, you want to make something, but you follow or you add up very many things to make that substance. That's the simplest way you can describe synthesis. So direct synthesis, like now here, we are looking at get two elements, make them or combine them together. So the process of combining them together, you are trying to form a new substance. The process is called synthesizing. So what other method can we use? Insoluble salts, we use only one method. That is double decomposition. You get two soluble salts. When they react, they give you one soluble and then one insoluble. That is what we mean by double decomposition. Can one use any element of their own choice? As long as it is in this category. As long as it is in this category, you don't need to struggle. Now, an example, they will ask you, how do you prepare iron 3 chloride? You don't need to look for, maybe they will put 3 marks. You don't need to look for the hardest way of getting it. Just fuse iron, pass it through heated chlorine, you will form iron 3 chloride. Elizabeth, are you getting it?
Yes, teacher must use a chloride.
Yes, if you want a chloride salt, use a chloride. If you want a bromide salt, use bromine.
Okay, teacher.
Okay. So, let me go back to this procedure we left behind. Then we see the keys there. Okay. Here, we are looking at this way of preparing these salts. We left it behind here. Now, these salts that include potassium, sodium, and ammonium salts. These salts can be prepared by titration method. Now here, if you ask Mr. Google, sir, he will show you how to come up with titration method. You ask Mr. Google, sir, he will get us the equipment we use for titrating. The first equipment is what? A burette. Yes. We use a burette. Secondly, we use what we call a conical flask. Pipette. Are these the only 3 things? We use beakers. Those in the senior 3 who have ever done titration, which other equipment do we use apart from these ones?
Retort stand.
A retort stand. Retort stand. Now, senior 2s, we know how a retort stand looks like. Isn't it? Yes?
Yes.
Good. We know how beakers look like.
Yes.
Okay. Do you know how pipette looks like? Who is that person there? A pipette, conical flask, and a burette. Now, if there is this whatever here, we have this simple video we have here. We have this simple video here. It is going to show us how titration comes about. Here, this is part 1, titration technique. That is his name. So this is how you perform titration of the unknown. So if titration, you are quantitatively, this is quantity. You know the word quantity? Yes? What's the difference between the quantity and the quality?
Quantity is
Yes.
the amount.
This is amount, correct? Then quality? Quality.
Quality is
product. It is a what? It is a product.
No.
Yes.
How the product is like.
How the product looks like. It is either good quality or poor quality. So use the same word. So quantitatively, this is just quantity, the amount, to determine the amount or the concentration of the unknown solution. You are using one you know to determine the other one that you don't know. So this is the whole process here. So what they mean by a titrant or the analyte. Analyte is what the volume of what you are going to get. This is the unknown, the analyte. You are trying to analyze it. It comes from the word analysis or analyzing. So if you are trying to get the volume of the unknown, something you are trying to get to know its exact volume. The titrant, you must know its volume. So the titrant, you always put it in the burette. The analyte is always in the conical flask. So our conical flask, so also look at down there. So when you add these two, you get the volume of a chemical with the volume of a chemical with the known concentration. This is our so here is trying to elaborate how these things come about. You get two solutions. Now these solutions, all of them are soluble. We looked at indicators before, This one change the color of any substance as long as the pH or the pH of a certain solution changes. Now, we must know how to use the indicator. If you add indicator to any of these solutions and titrate with the other solution, when the color just changes, that is our quantity or the amount of the volume needed to neutralize or to get the salt. Now, at that point, the salt you need has been formed. That is called a trial experiment. Then you go back and get the same exact volume you have used here and add the two salts. Then you follow the other procedure of ours of saturating. Let's continue. So the equipment they use for titration, this is a burette they are using. This is a clamp. This is a burette. It has a tap down. This is a clamp for holding the burette. This is the whole setup of a clamp, and this rod here is what we call a throat stand. This tap regulates the flow of the liquid, and the markings are there. This is the whole setup they use. Materials you need, this is a filter funnel, but in most cases we don't use it. We take it as a time waster. This is a conical flask. Somebody was saying no, so now this is how a conical flask looks like. This is our pipette, and then this is a pipette filler. So as here, we use the mouth for filling the pipette. If somebody is given this, I don't know how many people will get them, but when you go further to the university, you will not be using the mouth. You will be using this kind of things. But from that low level, we use the mouth for filling this. Wash bottle is so this is the indicator. So most of us who cannot see the color changes properly, you can use this white sheet of paper to help you know the rightful color. So it's cleaning the burette. You make sure you use clean equipment. So that is the way you open the tap and water runs down. So it's trying to show you how you wash your burette. You tie back the burette. That is the way you tie or you put your things together. Put the funnel. This funnel helps you to pour you one of the solutions here. An example, if you want use sulfuric acid, and maybe if you want a salt of sodium sulfate, you can use sulfuric acid and sodium hydroxide. Those are two soluble salts, hydroxide and the acid. So we are going to determine sodium sulfate using titration method. So we fill the burette with sulfuric acid. He's trying to check the burette if there's any air bubbles down. You find when you pour acid, at the end of this column down here, you find there are some air bubbles coiling there. So you tap on your burette a little to remove those bubbles. So you remove the funnel when you are titrating. So it's now going to add up the other solution and the indicator. Now, when you are reading this volume, there is what we call meniscus. Now here we have two. There is the upper meniscus, upper, and then we have the lower meniscus. Here, you see where this mark is, down. Yes? Are we there?
Yes.
Okay. Now below, use your eye very well. Below this, there is a mark here down. You see this? Then there is that lower mark. That lower mark is what we call the lower meniscus. Meniscus is that curve that comes that way. So there are two always. There is one up, then there is one down. Now we don't use the upper meniscus here, this one, for determining the volume of the burette to use. We use always this lower meniscus, the lower one down, that is the accurate volume of the liquid used. This one here has some interference in it. You can't use it. So the lower one is the one we read. So it's trying to make sure that it reads the accurate volume by using the guide of this dark bit of this paper. If you leave it open, you might not read it carefully. Now, when you are reading these titrations, we get final volume, initial volume, then the subtraction of the two gives us the volume of one of the solutions used. Volume of the titrant or volume of the solution used. You use always 2 decimal places to record the volume. 2 decimal places. Beyond the smallest graduation. So
Teacher.
you use, yes.
Teacher, the lower the initial volume.
Yes, the lower meniscus, always where the water stops before you even start titration, gives us the initial volume. Is it clear? So that lower meniscus, before you start any titration, you record that as your initial volume to 2 decimal places. So the same idea of the lower meniscus, you get it and use it for reading the pipette. So the way you saw that meniscus on the burette is the very same way you should do pipette or to get the liquid into the pipette. You always use the lower volume. The lowest meniscus should be at the mark of the pipette. You allow it to withdraw to go through and forward. So it's adding indicator to that. So it's titrating now. Now, the end point is determined by the change in color. You see, when you add the drops of the acid into this solution of ours, the solution is turning pink. But if you continue shaking, the pink color disappears. So you wait until when that color persists or when it just changes. That is what we call the end point. So it's continuously shaking the flask. So now when this color just changes, you see a permanent color change. You stop there and take the final volume reading. You see, even if you add more acid, there will be no more color change. So that is what we call titration process. Any question before we go back to our point of discussion? Yes?
What are the analytes put in the conical flask?
Aha. In that process, you are trying to analyze some things. If you want an example of sodium sulfate, salt, isn't it? We use one acid, that is sulfuric acid, and then one of the base or one of the alkali, which is sodium hydroxide. Now, this one is put in the burette. This one is put in the conical flask. Now it depends on which one you want. You can either put this in the burette, or the reverse is true. So whichever, as long as you want to determine the volume of one. After all, when the two react, they give you the final volume of the product you want. That's sodium what? Sulfate. When the color changes, if you use phenolphthalein, that was colorless. Phenolphthalein. This is an indicator. It is always colorless. When you add it to sodium hydroxide, turns pink. When you add it to acid, it remains colorless. Now, when the two react, when you add acid to this, it will turn from pink to colorless. When you add this to this, it will turn from colorless to pink. So that is the only difference when you add the two. So here, this can be your analyte. You are trying to form this. Well, those are the two analytes you use. Is it clear? Yes?
Yes.
Okay. Now here, you prepare these salts by one. General procedure is put a known volume of hydroxide of a metal. Hydroxide of a metal. This is an alkali. Alkali gives us hydroxide ions as the only negatively charged ions. So here, you add a known volume. The volume of this must be known. Then the acid, then you add indicator. Run a suitable acid from the burette until when the color of the mixture just changes. Note and record the volume of the acid used. Now, this is like you are trying out whether a salt can be formed. This is a trial. We don't need that color in our salts. Okay? So we remove the indicator. We don't use the indicator. That's why we say, now go back to the same. After knowing the volume of the acid you use, you measure now accurately the volume, the same volume of the hydroxide used as before. Then now, NB, indicators is not used in the second titration. Since the volume of the acid required to neutralize is fixed, we don't need to put your indicator in our salt. This is like an impurity again. Just measure accurately the same volume you have used, just like the way you titrated up here before. Now, add the same volume of the acid, since you have known the volume that's required to form the salt. Then you stir them together. Stir and heat the solution to make it saturated. That is back to our formula. Allow the hot solution to cool as the salt forms. Then the crystal will be formed or washed and dried in an oven. Is the procedure clear? Yes? Sophie. Any question? Romeo? Anything that's not clear with this procedure? Because we have seen the video how to titrate, we have known how to make the solution. Now, if you want to prepare any salt of potassium, sodium, and ammonia, this is the correct procedure to be used. Place a known volume, just titrate with the indicator. This one gives us to know that this is the volume of the acid used. Now, if you know the acid used, we don't need an indicator in our final salt. So you measure out the exact volume of the acid you used up here. Then you add the exact volume of the acid you used to neutralize that salt here. So after you have formed the salts, stir them together. Go back to our procedure that says stir and heat the solution to make it saturated. Saturate it by heating. Allow the hot solution to cool as the salt forms, and then the crystals will be formed. You wash and dry. Any question of how to come up with these salts? Yes? We have known how to prepare soluble salts, insoluble, And then finally, salts of potassium, sodium, and ammonium. This one is titration. This one is precipitation or double decomposition. Then this one, we use the other four methods that we have looked at. Any question before we continue, before we close the program or the chapter for today? We have less than a minute. Yes?
No question.
We can now prepare the salts.
Yes, teacher.
Oh, yes?
Apart from crystallization and neutralization in soluble salts, what other methods are there to get the salts?
There are many. You can use carbonate and acid. You can also use the hydroxides. You get? Yes?
Yes, teacher.